Okay, we're going to work through a series of questions. I'm going to, as this video proceeds, I'm going to propose tasks that you have to do. And what I want you to do every time I give you a task, I want you to pause the video, do the task, and then restart the video. Okay, so let's get going. So the first thing we're going to do, as always, is library tidyverse. Remember, almost any time you do anything with me, that'll be the very first thing you do. Now, in the tidyverse, there's the ggplot2 package, and within the ggplot2 package, there's a sample data frame called MPG, and I want you to just examine that. You can use glimpse to examine it, okay? So again, what I want you to do now is stop the video, do the task, then restart the video, okay? Okay, let's go on. There's the result of glimpsing, and you can see all the variables in the data frame. There are 234 vehicles, and highway gas mileage is one of the things it's what we're going to try to predict using a linear model. Okay? So our first task is to build a model to predict highway. And I want you to create a model of the form highway is intercept plus slope times displacement. And use the LM function to create this thing. We'll call it model 1. Okay? So stop the video and create the model. Okay, you're back. I hope you were successful in creating the model. Here's the way I did it. It says model 1 is LM, parentheses, highway tilde displacement, comma, data equal MPG. Now use summary to look at model 1. And again, stop the video and use summary and look at model 1. Then restart the video after you're done. Okay, there's the summary of model 1, and I'll point out the interesting things in it. It says the intercept value is 35 point blah blah blah, and the displacement value is negative 3.5 blah blah blah. And you see the summary statistics. The one that I'm most interested in, I'm a little bit different than the authors of the book. I look at the residual standard error. You can think of this as being the typical mistake that the model makes when it does a forecast, which is 3.8 miles per gallon. The Xi book focused on R squared, which is 0.5868, and don't worry about the adjusted value at this point. So it says that you're explaining roughly 59% of the variation in the model. Okay. What are the values of intercept and slope? Okay. So answer that question. This should just take you a second. I just gave you the answers. So anyway, pick them out and write them down. Okay, assuming you've done that, the intercept is this, 35.6977. The slope is this, minus 3.5306. And again, we just take those right out of the summary output. So I want you now to write down the equation. And actually, you should write this down on paper, or you could do it in RStudio. Okay, let's stop the video. And after you've written down the equation, restart the video. Okay, so here's the equation. Highway is intercept minus slope times displacement. And I want you to use this equation to calculate the value of HWY when DISPL is 2. And call this highway 2. Okay? So take a second to do that, then restart the video. Do the same for an engine with 3 liters displacement. Okay, stop the video, do it with 3 liters. Then I assume you've done that, so let's look. And now, here's highway 3. And subtract highway 2 from highway 3. And you see that the difference between highway 3 and highway 2 is negative 3.5306. That's a familiar number, right? That is the value of the slope. And that is an important concept, that increasing the displacement by 1 adds the value of slope to highway. I say adds in quotes because the thing that you add is a negative number, so it actually decreases the value of slope. Okay. So our basic framework, the data does not lie exactly on the line we have estimated. Show this graphically using a scatter plot of HWY and DISPL. Add a smoother with method equal quote LM quote. And this is the smoother that you get will actually be exactly identical to the regression line that we just estimated. Okay, so this will take you a few minutes, so stop the video and do the work and then restart the video. Okay, you're back. So we start with MPG and then do a GG plot with the aesthetics. X is displacement and Y is highway. And we'll do a GM underscore point, color equal blue, plus a GM underscore smooth with method equal LM and color equal red. And this is what we see. Let's look at that and see what we observe. There's a lot of good conformity to the equation, except for very low values of displacement. You have this cluster of points which are way above the regression line. And again, out here, you have another cluster of points. So for very low values and very high values, the actuals are above the predicted line. So you have positive residuals. That suggests that you might want a quadratic model. So it would do kind of a first declining, then at the end increasing slope. Okay? So let's look at the contents of Model 1 using STR. It's very simple. Just say STR parentheses Model 1. So again, stop the video and carry that out. Then let's come back and talk again. Okay, you're back. So let's look at the results. Here's the structure of Model 1. And you see that the LM function really produces a fairly complicated object whenever you run it. And look at some of the things that are in it. A lot of this you don't need to understand. The coefficients. There's a vector of length 2 containing the coefficients, which you recognize. And there's a vector of residuals, 234 observations. Now the residuals are very important in trying to diagnose what's going on with a model. Okay, so they're there. We could get at them. Okay. So extract the item residuals from the model and see what it is using str. Okay, so again, this is a task that you need to perform. So extract the residuals from the model, stop the video, extract the residuals from the model, and then look at the str of residuals. Okay, you're back. Let's look at that. Residuals is model 1 $sign residuals, and if I look at the structure residuals, it just says it's a named numeric vector, 234 elements, and the names are simply sequence numbers 1, 2, 3, 4. Now I want you to create mpg_augment by adding the vector residuals to mpg using cbind or column bind. Okay, so stop the video, get that done, then come back and we'll talk again. Okay, you're back. So mpg_augment is cbind of mpg, comma, residuals. So the next thing we want to do is create a scatter plot of displ and residuals. So stop the video, do the work, then come back and restart the video. Okay? Okay, you're back. So here's the thing we wanted to do. We start with the data frame mpg_augment, and there's the ggplot. X is displacement, Y is residuals. gm_point, color is equal to blue. And we do a geom_smooth. Method is lm, color is red. And what that does, because the residuals don't have any upward or downward trend really, a linear model to them is just simply a straight line, horizontal straight line at 0. So you can see what we've seen before. Here are the positive residuals for the very low values, and the cluster of positive residuals for the very high values of displacement. Okay. So what we did when we manually created that model, we just copied numbers from the output of summary. There's actually a function built into R which enables you to get predictions. So I want you to use predict to create estimates of highway for values of displacement running from 1 to 11. Note that the value of displacement must be in a data frame, so you can create the vector displacement, and then when you put it into predict, it has to be a data.frame of displacement. Even though there's only a single variable, you make it into a data frame, and it's just that the predict function requires a data frame. There was an error in the Xi book which suggested that you could get away with just sticking in a vector, and no, you can't do that. It has to be inside a data frame. Okay, so go ahead and do that. Stop the video as usual, and after you've finished doing it, restart the video. Okay, so I created displacement is C of 1 colon 11, and then I created something called new data, It's just a data dot frame of displacement, which is just the vector with a built into a data frame, although there's nothing in the data frame but the vector. So predictions equal predict of model 1, comma, new data. And the results is data dot frame of displ, comma, predictions. So I create a new data frame called results, which has the values of displacement and the value of the predictions. Okay. So let's look at the predictions together with the real data. Okay, so you're going to do basically a scatter plot and then add the predictions. Okay, so stop the video, do that, then take a look. Okay, let's take a look. So the first thing I did was to do the scatter plot of displacement and highway from the actual data. Then I did a second g_underscore point, and I did not use the data from MPG, I used the data from results. And it's okay because the horizontal axis is the same. So I still got displacement on the x-axis and predictions on the y-axis. Here I had highway on the y-axis. Here I have predictions on the y-axis. Okay, and I can tell which points belong to this because they will be red. So if we look at the graph, you can see basically the line, the linear model traced out by the red points. And then you see something kind of interesting. And this will always be true with a straight line with a negative slope. That is, if you go far enough to the right, it will eventually become negative. So this is the danger of extrapolation. And in reality, we should not really be we should not try to make predictions based on displacement for much above 6 liters, okay? Clearly, these points out here are not justified by this model. Okay, so that concludes this particular little presentation on regression.